Okay, I hope I'm audible to all the students who are attending this lecture. We continue with the concept of relations. And in the last lecture of relations, we had looked at the property of reflexivity and symmetry. So we continue with the same topic. So types of relations on X, types of relations on X. First was reflexive, second was symmetric. Covered in the previous lecture. Symmetric and reflexive, which were covered in the previous lecture. Now let's write the third one, anti-symmetric. Anti-symmetric. So a relation R on X is said to be anti-symmetric if and only if X is related to Y and Y is related to X, it implies X is equal to Y. For all small x and small y belonging to the set capital X. So guys, now what is my hypothesis? This is my hypothesis. What is my conclusion? This is my conclusion. If you all can recall my lecture on symbolic logic, this is my statement P, which is the hypothesis. This is Q. This is the hypothesis. And this is my conclusion. Okay, so let's understand this using an example. So consider X is equal to 1, 2, 3, 4 and define a relation R1 as set of 1, 1, 2, 2, 3, 3, 4, 4. Guys, is it anti-symmetric? Let's check. X is related to Y and Y is related to X implies X is equal to Y. You can see 1 is equal to 1, 2 is equal to 2, 3 is equal to 3, 4 is equal to 4. So you can say that this relation is reflexive also and it is anti-symmetric also. This is reflexive and anti-symmetric both. Why is it reflexive? Because X is related to itself for all X belonging to capital X. Why is it anti-symmetric? Because if X is related to Y and Y is related to X, you can see X is equal to Y. But guys, if I consider another relation, if I consider only this, is it reflexive? No, not reflexive. Why? Because 4, 4 does not belong to R2. But is it anti-symmetric? Yes, it is anti-symmetric. Because in the anti-symmetric definition, look at the definition. What was it? If X is related to Y and Y is related to X, X should be equal to Y. So you can see in all these cases, X is equal to Y. So what have you understood? Every reflexive relation will be antisymmetric, but every antisymmetric relation will not be reflexive. This is what we have learned. Every reflexive relation is antisymmetric, but every antisymmetric relation may not be reflexive. For reflexivity to hold true, x should be related to itself for all values of x. But that does not necessarily hold true for antisymmetric. For antisymmetric, all what matters is that if x is related to y and y is related to x, x should be equal to y. So guys, if I erase all this and if I just write this, is this reflexive? Not reflexive. Because why? Because 2 comma 2, 3 comma 3 and 4 comma 4 does not belong to R. It's not reflexive because 2 comma 2, 3 comma 3, 4 comma 4 does not belong to R1. But is it antisymmetric? Yes. This is antisymmetric. Why? Because you can see x is related to y and y is related to x implies x is equal to y. 1 is equal to 1. So I hope all students have understood this. Another way in which I can say is that antisymmetric relation will be a subset of reflexive relation. Antisymmetric relation will be a subset of reflexive relation. That means every reflexive relation will be antisymmetric, but every antisymmetric relation may not be reflexive. Okay, so let's please ask your doubts.
The relation R1 and R2 can also be called symmetric relation, no?
Yeah, R1 and R2 both are symmetric. Relations R1 and R2 both are symmetric because of vacuously true concept. Okay, now let's define transitive. This is the fourth type of relation, transitive. A relation R on the set X is said to be transitive if and only if X is related to Y and Y is related to Z, implies X is related to Z. For all small x, small y, and small z belonging to the set capital X. So what does the transitivity property say? If X is related to Y and Y is related to Z, then X is related to Z. For all X, Y, and Z belonging to the set capital X. Let's understand this using an example. Consider X as 1, 2, 3, 4. Suppose my relation R1 is First of all, I ask you, is it reflexive? Not reflexive. Why? Because 1, 1, 2, 2, 3, 3, and 4, 4 does not belong to R1. Does not belong to R1. None of them belongs to R1. Is it symmetric? Not symmetric. Why? Because 1, 2 belongs to R1, but 2, 1 does not belong to R1. Is it transitive? Yes. Yes, it is transitive. Why? Because 1, 2 belongs to R1 and 2, 3 belongs to R1 implies 1, 3 also belongs to R1. X is related to Y and Y is related to Z implies X is related to Z. So this relation is not reflexive, not symmetric, but it is transitive. So I hope students have understood that. Let me take another example. Is this relation reflexive? Yes, it is reflexive. Since 1, 1, 2, 2, 3, 3, 4, 4, all of them belong to R2. Is it relation symmetric? Yes, it is symmetric because of vacuously true. Hypothesis itself is not there. Guys, is this relation transitive? Yes. It is also transitive, again because of the concept of vacuously true. Because when I define this relation, is hypothesis meeting true? What is the hypothesis? This is the hypothesis. You will see in this case, hypothesis itself is not meeting true. In the above example, hypothesis itself is not true. Therefore, we need not worry about the conclusion. Therefore, we need not worry about the conclusion. Therefore, by default, the above relation is, by default, the above relation is transitive. So guys, whenever the hypothesis itself is not satisfying, the statement will always be true. When will the statement be false? If the hypothesis is true, but conclusion is false. So the moment I put 1, 2 here, the moment I put 1, 2 here, not symmetric. Okay, the moment I put 1, 2 here, not symmetric. And the moment I put one more thing here, suppose I also put 2, 3, it will be not transitive. It will be not transitive. Why? Why is it not symmetric? Because 1, 2 belongs to R2, but 2, 1 does not belong to R2. Why is it not transitive? because 1 comma 2 belongs to R2 and 2 comma 3 belongs to R2, but 1 comma 3 does not belong to R2. So I hope all students attending the lecture are finding it interesting. It's a very interesting concept. All you need to do is understand it properly. So we can write a note now. R is said to be an equivalence relation. R is said to be an equivalence relation on X if and only if R is reflexive, symmetric, and transitive. That means if the relation R satisfies all these three properties, it is an equivalence relation. And second point, R is said to be a partial order relation. R is said to be a partial order relation on X if and only if R is reflexive, anti-symmetric, and transitive. So if a relation is reflexive, symmetric, and transitive, it is called an equivalence relation on X. If a relation is reflexive, anti-symmetric, and transitive, it is called a partial order relation on X. So I hope all students are clear with this. Then let's do 2 questions and then we stop. Okay. So practice question 1. Define a relation R on the set of integers. Guys, set of integers we denote by Z. It's the standard symbol for integers. As X is related to Y if and only if X minus Y is a multiple of 5. Show that R is an equivalence relation. How will I show this? I will have to show that R is reflexive, symmetric, and transitive. So guys, let's check for reflexivity. So you can see that X minus X is equal to 0, which is a multiple of 5. Therefore, X comma X belongs to R for all X belonging to the set of integers. Therefore, I can say that R is reflexive. Because X minus X is 0 and 0 is a multiple of any number. So R is reflexive. Is it symmetric? So X comma Y belongs to R implies X minus Y implies X minus Y is a multiple of 5. Guys, if X minus Y is a multiple of 5, it also implies that Y minus X is a multiple of 5, right? If X minus Y is a multiple of 5, then Y minus X is also a multiple of 5. which implies y comma x also belongs to R for all x and y belonging to the set of integers. Therefore, R is symmetric. And now let's check for transitivity here. Let's check for transitivity. So consider x comma y belongs to R implies x minus y is a multiple of 5. Guys, how can I write it mathematically? It means x minus y is equal to plus minus 5m, where x and y are integers. I can write it like this, right? If x minus y is a multiple of 5, it means x minus y is equal to plus minus 5m. Consider y comma z belonging to R. It implies y minus z is also a multiple of 5, so plus minus 5n, where y and z belong to, where y and z are integers, where y and z are integers. Now guys, if I add 1 and 2, adding 1 and 2, x minus y plus y minus z is equal to plus minus 5m plus minus 5n, yn minus y cancel, x minus z is equal to 5 times plus minus m plus minus n, which implies x comma z also belongs to R because x minus z is a multiple of 5. Therefore, I can say that R is transitive. And from 1, 2, and 3, let me call this as Roman numeral 1, and so that there is no confusion, let me call this as Roman numeral 1 and 2. So from 1, 2, and 3, R is an equivalence relation. We have shown that R is reflexive. We have shown that R is symmetric. We have also shown that R is transitive. X comma y belongs to R. X minus y is a multiple of 5. Y comma z belongs to R. Y minus z is a multiple of 5. If I add them, I can see that x minus z is also a multiple of 5. It means x comma z also belongs to R. Therefore, R is transitive. Since R is reflexive, symmetric, and transitive, it is an equivalence relation. Okay. And guys, the last question for the day, after which I stop. Practice question 2. Consider a relation R on the set Z of integers defined as x is related to y if and only if x is less than equal to y. Show that R is a partial order relation. Show that R is a partial order relation. Let's look at the solution. To show that R is a partial order relation, we need to show it's reflexive, anti-symmetric, and transitive. Let's check for reflexivity. Now we know that x is less than or equal to itself. for all x belonging to integers. We know that x is equal to itself, right? So I can write it like this. Therefore, x comma x belongs to R for all x belonging to Z. Therefore, R is reflexive. Let's check for anti-symmetry. There is no need to check for symmetry because we need to show it's a partial order relation. That means we need to check for anti-symmetric. So let x be related to y and y be related to x. This implies x is related to y means x is less than equal to y and y is less than equal to x. Guys, what does this mean? If x is less than equal to y and at the same time y is less than equal to x, it implies x is equal to y for all x and y belonging to integers. Therefore, R is anti-symmetric. If x, point here to understand is, if x is less than equal to y and y is less than equal to x, it implies x is equal to y, which implies R is anti-symmetric. The last thing to show, transitive. So x comma y belongs to R implies x is less than equal to y, and y comma z belongs to R implies y is less than equal to z. So from 1 and 2, x is less than equal to y less than equal to z, which implies x is less than equal to z, which implies x comma z also belongs to R for all x and z belonging to the set of integers. Therefore, R is transitive. And from 1, 2, and 3, from 1, 2, and 3, R is a partial order relation since it is reflexive, anti-symmetric, and transitive. So guys, this is where I stop in the lecture. I hope all students have enjoyed the lecture today. Any doubts, you can unmute your mic and ask, or call up or mail your doubts at divineschooloфeconomics@gmail.com. So this is where I stop. Okay. So any student has a doubt, please unmute your mic and ask. Okay, guys, I stop here. Students who are not added to the WhatsApp group, please message me. I will add you to the group. Okay, we now meet next on Tuesday. So this is where I stop.